Copper is a chemical element with the symbol Cu and atomic number 29. It is a soft, malleable, and ductile metal. Its thermal and electrical conductivities are so high that it is widely used to make electrical wiring and in other applications that utilize its high electrical conductivity. Crude copper is not suitable to solve in electric applications because its impurities reduce the metal's conductivity. This video is all about the electrolysis of aqueous copper sulfate using copper electrodes. This method is mainly used in copper refining industry. What is electrolysis? Electrolysis is the decomposition of a compound into its component elements using electrical energy. We use a proper electrolyte in the process of electrolysis. Electrolyte is a liquid which contains ions and can be decomposed by electrolysis. In this experiment, we'll use copper sulfate solution as electrolyte. During electrolysis, the electricity passes through the electrolyte, making the ions in the electrolyte move to respective electrodes and then discharge. Electrolysis of aqueous copper sulfate using copper electrodes. Before we do this experiment, we need to understand what happens when the electrolyte undergoes electrolysis. As soon as the two copper electrodes, cathode and anode, are dipped in unison into the electrolyte, two reactions happen at the electrodes. What happened at the cathode? Cu2 plus ions move to the cathode. There, each Cu2 plus ion receives 2 electrons from the cathode and discharge. And a thin layer of copper is formed over the surface of the copper cathode. What happened at the anode? Every metal is made up of metal atoms, and so is copper. During electrolysis, copper atoms from the copper anode dissolve into the solution in the form of Cu2 plus ions. What happened to the color of copper sulfate solution? In this experiment, we'll find that the color of copper sulfate solution does not change. This is because Cu2 plus ions become copper atoms at the cathode and copper atoms turn into Cu2 plus ions at the anode, not only at the same time but also at the same rate. Now we're gonna demonstrate the electrolysis of aqueous copper sulfate using copper electrodes. The equipment required for this experiment are laptop 1, battery dish, dry cell battery 9 volt, electric wire with alligator clip, and micro dewing tube. And the supplies to be provided by teacher are copper wire pieces, clean water for washing hands, and the container for used water in solutions. And the container for used water in solutions. And here's the experimented procedure. Before we do this experiment, we need to wear gloves to avoid direct contact with chemicals. First, Place the petri dish on figure B of the laptop 1 sheet and 10 drops of copper 2 sulfate at the center, that is number 29, using a microdune pipette. This microdune pipette is one of the apparatus contained in the small-scale lab kit and very easy and convenient to use. In this solution, copper 2 sulfate ionized. It breaks apart into Cu2 plus ions and SO4 2 minus ions. Since it is an aqueous solution, it contains water, and the water also ionized as H plus ions and OH minus ions. Now, clip each of alligator clips to positive and negative terminal of 9-volt battery. Clip one of the pieces of copper wire with the other ends of each alligator clip. One clip at the positive terminal and the other negative terminal. Now, the tips of the copper wire pieces are partly immersed into the solution slowly and with full of care. That is, be careful not to touch each other. Leave them in the solution for 2 minutes. During the electrolysis, reduction occurs at the cathode. So, which one will reduce, Cu2 plus ions or H plus ions? The answer is Cu2 plus ions, because the reduction potential of Cu2 plus ions is higher than that of H plus ions. On the other hand, oxidation occurs at the cathode. Which one will oxidize, SO4 2 minus ions or OH minus ions? Neither, because the anode, which is copper itself, has more oxidation potential than these two ions. So copper anode dissolves into the solution as Cu2 plus ions as it oxidized. It will be found that the cathode is getting thicker, and the opposite is true for the anode. After 2 minutes, take the copper wire pieces out from the solution and check out the difference of copper wire pieces before and after electrolysis. Examine what happened to the color of the solution, and then it is found that the color of the solution does not change because the amount of copper deposited at the cathode is observed to be same as the amount of Cu2 plus ions dissolved in the solution from the anode. In other words, the color of the solution does not change because there is no change in concentration. After experiment, clean all equipment with purifying water and make sure to put the waste in the rubbish bin systematically or destroying in order that there is no harm. In our school, we always have a rubbish bin for chemical waste, and we also destroying the waste systematically after that.